Dun-dun-dun. Luke, how do you think this is gonna work?
It's doing pretty good.
Sure it is. You can run it back through there if you want to. Who needs more dirt? I mean, more water.
Me.
Colby, could you create more of a death trap for people here? If you're not going to filter, at least move this out of the way.
Nothing has come out of mine.
Mine isn't too bad, honestly.
This is what dreams.
Hey tubers, we are
Yours
filtering
is not going
water.
through. Rachel's has not gone through.
Yeah, I have like, where's the camera? I have 2 drops of water in there. It looks like watered down coffee, if any of y'all know what that's about. It's working beautifully, guys.
Mine is actually, I mean, it's kind of dirty. It's a little murky.
It's a little murky. Oh, I should probably
People on YouTube land, drop in the comments what you think about my water. Yours is just staying at the top. It's embarrassing.
If you're watching this, comment "da-na-na."
Yeah.
Do your best to spell it. I couldn't tell you how to spell it. Oh, no. If you're watching this, comment "Pirates colonized the islands."
That's a little bit problematic, Rachel.
How's that problematic?
It just is.
Not the islands like the Pacific Islands. Is that a thing?
Yes, Pacific Islands.
Yes. Okay, not the islands like those islands, but just islands in general.
Pacific Island is like Hawaii.
Yeah, that's not what I mean. Just comment "Pirates colonize islands."
Okay, queen.
Right? Is it colonized? Is that the word?
Yeah, I mean, I guess.
Yeah.
Or like inhabited or populated. That's
Populated, yes. Pirates populated islands.
Yours is awful.
I know.
It's
not
dirtier
working.
than mine and it's not coming out.
Please. Don't tell anyone, but I stole this from my cousin, so I didn't make this.
You told Mr. Mac.
Yeah, I did tell Mr. Mac that. Sorry,
You
guys.
actually know. Okay.
I cheated.
Alright, we're done. And now we're going to measure it. See how much is in there. Woohoo!
Thank you, Luke.
Oh, wait. You want to wash that up?
Hold on, I'm measuring how much is in it. Also, don't tell my name to people in internet land.
Lucas, that's not your name.
It's 48. Mine's 48. Woohoo! 48.
Okay. I'm just gonna put that in there.
Okay, mine. Would I drink this? No. But is it?
Would I drink this now?
Alright, when you're through, measure it. You can just whip it in that corner. You measure how much you got, and then if you think yours is fairly clear and you want to compare it, then you bring it up here and sit it on our
What?
card.
Some sweet tea. That's nasty, Donovan.
I would drink Caleb's.
I would drink mine. I'll do it right now.
Are you using this?
Not a lot.
No. Huh? No. Here, do it for the people on YouTube land.
Hey, the telephone bill. That's clear. I measure it and then put it over here and we'll see how it compares. Put it on the white. No, it's not that great. Did you turn that on? Okay, Donovan, you're on TV, buddy. You have fun over there. Hey, turn the iPad off for me, Bella.
Just turn it off.
Yeah.
Hello, people in YouTube land. So I won't show my name, but this is my sticky note. So basically, to find your flow rate, you're supposed to measure in a, what's that thing called? Cylinder. Graduated cylinder. How much water you collected, and then you put it down in milliliters. So I got 8 milliliters, and then you put how long you did it, 4 minutes. So you do 8 milliliters divided by 4 minutes, and your filtration rate for me is 2 milliliters per minute, which is sad and depressing.
Mine was 5 milliliters per minute, and I said it was very clear I would drink it. But, however, I think I got a whole, maybe.
And mine was not clear. It was dirty, and it looked like watered down coffee.
Mine looked like a drink. Look at my hands, my nails. I cut them this morning. Okay. Bella, you want to show the camera?
I had 23 milliliters per minute.
That's amazing.
Mine was yellowish. There. It's not like lemonade.
Okay, bye YouTube land. Say bye.
Bye.
Hello, friends on the internet. Luke shared earlier his water filtration device, and also who else shared? Rachel. Yes. So today we tested water filters. What was the purpose of that water filter that we did? What would I ask y'all to take a plastic bottle and some sand and rocks and try to make a filter that clean water? Donovan?
Possibly try to find a way to help with like resources, like in some countries they aren't able to, their water resources are contaminated with from textile industries, factories.
Yeah, so like the video we watched on Indonesia the other day where poor people in undeveloped countries are living in conditions where they don't have clean water. Is there a way to take simple things like just some gravel and some sand and use that to clean and filter your water somewhat? And so we saw that some of you had much better luck than others in that process. How many of y'all actually did any research or watched a video on how to set up the filter? Sophie, you did?
Yeah.
How was your execution of that?
Clearly not very good.
Who had the best of it? Was it Colby? What did you have mostly in yours?
Me or Layla?
Yeah, you and Layla. Did you have mostly sand in yours?
It was like sand, charcoal, and then like rocks at the top.
Yeah. If you ever watch any of those survival shows, you'll see a lot of times they use charcoal in there. I think that's is kind of a antimicrobial agent. So I didn't really tell y'all to use that just because the dirt that I had wasn't something we were really looking at. We were just looking at clarity. But if you were out somewhere and trying to create some type of water filtration device, that would definitely be something you could use. Sand is important, and then also the rocks and gravel, like layering them kind of as you get bigger toward the top. Basically, what happens is that dirty water flows over it. The bigger the surface area of those particles, it will grab a hold of the dirt in the water. And so you're just basically grabbing the big stuff at the top, you're grabbing smaller stuff, and you continue all the way down to where hopefully you've removed most of the material in the water. Now, that's not you couldn't use that long-term forever because you'd have to replace it because eventually it would build up with dirt. But that is a way where you could get clean water fairly easily. And that's essentially what happens in the soil, right? Water rains on the ground and it flows down through there. And that's why if you get well water out of a well that's not adjacent to a super dirty river, then you would expect that water to be pretty clean just because it's going to filter most of that water out as it goes through the earth. All right, so that was the goal of the water filtration lab, and hopefully y'all at least learned a little bit about how to clean the water. That water was pretty nasty I gave y'all. Y'all saw it had a lot of stuff in it, and so most of y'all did pretty good. I think some of y'all who had dirty water, Donovan, and who else was it? Caleb, yours was kind of murky. I think most of that was actually from stuff in your dirt, not the stuff I poured through. Because the stuff I poured through, it was just black from the black soil that was in there. So I think some of the stuff that y'all had come out actually probably came out of your soil. And I guess if you ran some water through there enough, probably it would have cleared some of that up. Number 42. So, recycling. Colby, grab those two bottles right there. So, hand them to me if you will. So, recycling is doing what? Taking something and making it into something new or different or better. Yes. So, I've got a couple bottles here. I'm going to pass them around. We've got a Mountain Dew bottle. Somebody gave me these a couple years ago as a gift because I like soft drinks. I like soft drinks as much as the next person. This one I'm going to pass around because on the back here it shows the return rate. I don't know. I'm going to have to. Somebody we have to Google this here. The California says CRV by it. I don't know what that means. Michigan you get 10 cents back, and then all these other states you get 5 cents back. Here you go, Bella. Catch this. So. Anyway, so a lot of aluminum cans say that too. Now, this one, I think the future of if you're going to actually have people recycle or do something with their cans and bottles and stuff, just passing around, you're going to have to charge people extra, like 25 cents extra, and then you get 25 cents for turning it in. So, I don't know about y'all, but if I got 20 cents for every bottle and can I picked up on the side of the road, I'd be rich by now. So, maybe that'll be the future. I know in some places, like in Scandinavian countries, they almost look like vending machines, and you go and you put your bottle in, or your plastic bottle or most places don't have glass anymore, and you get like a return on it. So you can keep up with your stuff, go return it yourself, and you get the money back for it. A big problem we have now with recycling is there's just not very much incentive around here. And so we recycled at school for a while plastic bottles, and the problem we had is half of them were half full of water or Coke or something else, and it's hard to you can't take stuff in like that, and then you have to have somebody who goes through, opens everybody's bottle, pour it out, and all the stuff that goes along with that. It's really just it's difficult to do in the school setting. So if people were a little more responsible on their own, this wouldn't be a problem. Now I'm gonna pass this one around. Fanta's my favorite here, and you'll notice this is in Spanish. So, and you'll also notice the date on here when I pass this around. It says 1997. Somebody brought me this, and it was full in probably, I got this maybe 3 or 4 years ago. So, don't worry, I cleaned it out. Here you go, okay. So, that Fanta bottle right there, if somebody bought it and brought it to me, and it says 1997, and the writing's in Spanish, what could be the explanation for that? It came from somewhere in Central and South America. Now, I don't think she bought it and brought it from Central or South America. Why did it say 1997? That must have been some really old Fanta, right? No. It was? Yeah, the Coca-Cola company refills those. And so when we went to Costa Rica on a couple of school field trips in 2005 and 2006, we would go places, and so I like, I'm a heavy soft drinker, and so heavy soft drinker? That doesn't make sense. So we would go places, and you would buy like a Coke for $1. But when you take your bottle back, then it was only 50 cents because they gave you a 50-cent return, which is like as much as the Coke was. And so basically what they were doing is they were ensuring that people were returning all those bottles. They carry them all somewhere, they sanitize them, they refill them, put a cap back on them, and they sell them again. And so they're just reusing them over and over. Like when I was growing up, I remember we used to have a convenience store across from my grandmother's house, and the same thing. Like I would carry a bottle back and get like 5 or 10 cents off of it, a glass bottle, for the next one that I bought. And so that was to incentivize the return of those bottles, cans, plastic bottles, whatever it may be. So in the future, I don't know, one day we'll get to a point where maybe plastic isn't the most convenient way. Maybe we figure out it's not the best way. Glass is just made from what? Sand. And now, so you can get rid of it, throw it away, it breaks down. I mean, obviously you don't want to be like, the worst thing about glass bottles is like people throwing them out somewhere where you play. Like if you carry your kids to the beach or like a creek somewhere and there's glass bottles, you got to be careful. But you can break them down. Yes?
Do you know what that bottle says?
What?
Drinks are sold separately.
They're all sold separately?
That's what it says.
Okay. So they're not packaged?
And now it's sold
Thank you, Rachel, for translating for us. Yes. So the city recycles bottles. Does anybody know what they do with them? The glass bottles, if you recycle them in the city here at Tuscaloosa? They recycle them into mulch. So there's not a big industry for returning your glass around here. So that's the only thing that they found like that they can legitimately do with them. They basically grind them up into small little pieces of glass. Donovan, pass that on. And they tumble them so you can like touch and pick up this glass mulch and you won't get cut. Some people take it and they put it in like concrete as decorative concrete on places. So I don't know. We'll see what happens in the future of recycling, but I think that return is a good way to do that. All right, give me 2 more here. Recycling is one way to reduce current global demand on minerals, but the process is labor, energy intensive, and can be costly. A lot of our plastic previously was going to China, and China kind of put a ban on us sending so much plastic stuff over to them. I don't know if they just got inundated or what the deal is. But a lot of places in the U.S. have had issues dealing with plastic bottles because of that ban. So I don't know. We'll watch a video next week where we see how you go from plastic bottles and make clothing out of it, which is pretty interesting because most of us can't imagine wearing a plastic bottles as a coat, right? I should make a plastic bottle coat. That'd be cool. What?
Make a DIY video.
A DIY video.
You know, like you can take grocery bags and like shred them and make strips and then braid it. You should do that. You
Braid
it,
grocery bags, yes.
crochet it together.
You should do that. You should wear it to the prom. You would probably make the news.
I like a bag. Overalls, that would be so cute. Not to prom, just in general.
Super cute. Okay. And number 3, composting. Or number 4. Sorry. What is composting?
Composting is where you take animal waste and use it.
Animal waste? It can be animal waste, sure. You're not supposed to use dog or cat poop, any like human poop, anything like that that has a high protein in it. You're not supposed to use. You're not supposed to use any kind of meat or bread. What'd you say, Jordan?
Like organic material, like banana peels and stuff like that.
Yeah, mostly what you're using is produce. You're throwing it in a pile and you let it break down naturally, and you can use it as fertilizer. Does anybody have a compost pile at home? You should. Do you? What do y'all do with your compost? Is it in a bin or is it just in the side of the yard? Or?
No, it's in like a little bin that we like use as fertilizer.
Okay. We have I've got a couple pallets, actually I think 3 pallets up against one of my fences, toward the edge of the property, and we just pile all our waste produce there and then cover it up with a little bit of dirt every now and then use it on the garden. But you got to let it sit and break down for a while. The whole purpose of composting is just to reduce the amount that goes in the waste stream. Now, what you're thinking is, well, I don't have that much leftover produce and stuff to go in the garbage can. But think about the lunchroom. How much food gets wasted and thrown away there? Or at different restaurants. So that is a method of reducing that waste that could be recycled and used for fertilizer and around your home. And it's even worse if you're talking about big cities where people bag up their trash, or they bag up, not trash, their yard clippings or leaves and stuff. I know Atlanta, they have paper bags that they give customers. And so when they're bagging up leaves, they leave all these paper bags, and then they take that and shred it, and then they use it for mulch in the city. So there's better ways where you're not using up as much landfill space, okay? So today we're talking about graphing on our data nugget, and we've got a graph here, graph paper, and we've got some data that we collected and averaged. These are free online, by the way, data nuggets, in case you're looking for some fun graphs to do. Always do. Okay, so in that first graph, we've actually got a couple of independent variables there. What are the 2 different things that we're looking at? What?
Independent.
Time of the day.
Time of day, dusk and dawn, good. And what's the other independent variable?
Part of the estuary.
What part of the estuary, the upper and lower? So you're going to graph the data for the average dissolved oxygen that you calculated for the upper estuary at dusk and dawn, and then the average for the lower estuary at dusk and dawn. And so you're looking at oxygen levels. Okay, remember this whole graphing sequence is all about eutrophication in this estuary up in Massachusetts. All right, in the bottom graph, what are we looking at? What's the other thing you calculated? No. Standard. We'll talk about standard error in a second. We calculated the mean DO. No, that goes in the top one. What's the other thing that you've had to figure out?
Fluctuation.
The average fluctuation. So fluctuation was an indicator of, the fluctuation in DO from day to night would be an indicator of eutrophication. Because if you have a big transition, let's say that you have oxygen levels in the day and then they dramatically decrease at night. Why would they dramatically decrease? Well, the sun goes down, but that doesn't necessarily mean it's going to decrease. What would use up oxygen at night? Decomposers. So if there's stuff in the water that they're decomposing and breaking down, then that oxygen level is going to drop significantly at night when there's no sunlight out, and it'd go back up the next day. So if there's not a lot of decomposers in the water that are using up oxygen, then you wouldn't see as much of a fluctuation between day and night. Okay? So that's what you're going to be looking at, the fluctuation in the upper and lower estuary. Okay? So you guys will graph that out, and then, like I say, by about Friday, we need to have that sorted out where we get those graphs set up, and then we can worry about the questions. Okay?